Go.
Okay. Okay, guys, so this is the question that we were working on whenever we stopped the last video. We did part A, and we found, in part A, we found the wavelength, and we found that wavelength to be 1.1 times 10 to the negative 34th meters. And like we said, it is so super small that we cannot pick up on that type of wavelength because it's so incredibly small. So still those electrons to us look like they just are moving like particles probably to us, even though if we look at it on a tiny, tiny, tiny scale, it would be acting more kind of like a wave, okay? In part B, it says, should the catcher expect diffraction to occur as the ball passes through the opening to his mitt? Now, on this one, we haven't talked about diffraction yet, but we did just say that this wavelength, because it's so small, we're not going to be able to notice it, and that's the answer in part B. So because the wavelength is so small, we're not going to be able to notice anything. Okay, so even though we haven't talked about diffraction yet, we will talk about that on Monday or Tuesday of next week. The wavelength is so small, you as a human being will never be able to see that small of a wavelength, okay? All right, we have one more problem like this, and it is, what is the de Broglie wavelength of the wave associated with an electron that has been accelerated from rest through a potential of 50 volts? This is a really good question to bridge the gap between chapter 27 and 28, okay? Now, I know key phrase here, de Broglie wavelength. So I'm trying to find this wavelength here. Well, I know H, because that's given to me where, Felicia?
In the front of your book.
In the front of our book. So I know that H will be always in the front of the book. And I also know the mass of this. They don't give me a number, but what is my key word here that I know the mass of? What is it?
Electron.
An electron. And where can I always find the mass of an electron?
The front.
In the front of your book. So I know that H equals 6.63 times 10 to the negative 34th. I know that M of my electron is 9.11 times 10 to the negative 31st. That's kilograms. It's a joule second. Okay, so I don't know V, and I'm trying to solve for my lambda, so here's my problem. I want this, but I don't know this. But I can find this. How do you think we're going to do that? They gave you a voltage. They gave you 50 volts. And we know that that voltage is going to accelerate these electrons. As these electrons are being accelerated, that means that they have a certain amount of kinetic energy. I know the mass of the electron. I'm trying to find the velocity of the electron. They indirectly gave me the kinetic energy. 50 volts is my voltage, my electric potential. But in the last chapter, we had an equation where Kmax equals E times V. Do you guys remember that? Do you remember that? In chapter 27? So in chapter 27, we had Kmax equals E times V. And this is going to get us from volts to what's K measured in? What's energy measured in? Felicia?
Joules.
Joules. Yay. Okay, do we remember what the E stands for from chapter 27?
Isn't that a constant?
Okay, it is a constant. Specifically, it's the charge of the electron. So E will always be the charge of the electron that I will find where?
The front of your test
Front of the test booklet. Chemistry children, good job. Okay, so kinetic energy is equal to my E, which is 1.6 times 10 to the negative 19th coulombs, because that's a charge, times my voltage. And my voltage is what? What did they give me? 50? Okay, so formula, my E is just the charge of the electron, my V is what they've given me. When I multiply those two, I have my kinetic energy. And they did not do that for me in here, so we're going to have to do that together. Alright guys, we should get 8 times 10 to the negative 18th. And if we're thinking about this in terms of kinetic energy, then it should be what units?
Joules.
Joules. So I have my kinetic energy now. I know my mass of my electron because we have to look where? In the front of our book. So let's find our velocity, because once we find that, I can find my wavelength. Okay? So this is a very, very long problem that's trying to incorporate tons of chapters kind of into one problem. So I think that this would be a good example of a free response question where they would have like part A, find the kinetic energy, part B, find the velocity, part C, find the de Broglie wavelength. And they would probably walk you through it step by step like that too in part A through C. Okay? Okay, so I have my kinetic energy, and let's plug that in. 8 times 10 to the negative 18th joules equals 1/2. And then I had my mass of the electron, which is 9.11 times 10 to the negative 31st kilograms times V squared. Okay, I want V squared by itself. So the first thing I should do is take 1/2 times this 9.11 times 10 to the negative 31st. When I do that, I'll get one number times V squared. To get V squared by itself, I'll divide both sides by that. And then I'd be left with a number equals V squared. How do I get V by itself then?
Square root.
Square root it. Ultimately, your velocity should come out to be 4.19 times 10 to the 6th meters per second. Okay, so now I have my velocity. Let's write that over here. 4.19 times 10 to the 6th meters per second. Do I have everything I need now to find that de Broglie wavelength? I do. So let's plug in everything we need to find that wavelength, because that's ultimately what this question is asking me to solve for. So my wavelength equals, my h is Planck's constant, and I can always find that in the front of my book because it's a constant. So going to be h over, my mass is the mass of the electron. They didn't tell me that in the problem, but I knew the mass of the electron because first it tells me electron, and I know I can always find the mass where? In the front of your test book.